Hello friends, today we are discussing the subject microprocessor unit number 6. In this lecture, this is in part 12. It explains some of the bus cycles, thread 6 DS signal, thread 7 processor, some of the instructions which are the mnemonic FLD 32FP. The It explains that it pushes a M32FP onto the FPU register stacks. FLD 64FP, which pushes the 64FP onto the FPU register stack. FLD 18FP, which pushes the M18FP onto the FPU register stack. FLD STI, which pushes the STI onto the FPU register stack. FST M32FP, which copies the ST0 to the M32FP. FST 64FP, which copies the ST0s to the M34FP. FSTP M32FP, this instruction copies the content of the stack 0 to the M32FP and pop the register stack. FSTP M64FP, this instruction copies the content of the stack register pointer 0 to the M64FP and pop the register stack. FSTP STI, this instruction copies the stack register content at the location 0 to the STI and pop the register stack. FSUB M32FP, subtract the M32FP from the ST0 and store the result in ST0. FSUB M64FP, subtract the M64FP from the ST0 and store the result in ST0. FSUB ST0 STI, subtract the STI from the ST0 and store the result in ST0. FSUB STI ST0, subtract the ST0 from the STY and store the result in a STI. FSUB P STI and ST0, subtract the ST0 from the ST1, store the result in a STI and pop the register stacks. FISUB M32 integer, subtract the M32 integer from the ST0 and store the result in a ST0. FSUB M16 integer, subtract the M16 integer from the ST0 and store the result in a ST0. FSUB M32FP, subtract the ST0 from the M32FP and store the result in a ST0. FSUBR ST0 and STI, subtract the ST0 from the STI and store the result in a ST0. FSUBR STI and ST0, subtract the STI from the ST0, store the result in STI and pop the register stack. FISUBR M32 integer, subtract the ST0 from the M32 integer and store the result in the ST0. Mnemonics and description FMUL M32FP. That means the multiply the ST0 content of the stack location 0 by means F32FP and store the result in a again is ST0. FMUL M34FP, that is the multiply the content of the stack pointer 0 by the M64FP and store the result in a stack pointer 0. FMUL multiply the stack pointer 1 by the stack pointer 0 and store the result in a stack pointer 1 and pop the register stack. FMUL M16 integer, multiply the ST0 stack pointer 0 by the M16 integer and store the result in a ST0. Mnemonic and descriptions are here. FDI 32FP, divide M32FP by ST0 and store the result in a ST0. F division M32FP, divide the ST0 by the 32FP and store the result in a ST0. F divide M64FP, divide the ST0 by M64FP and store the result in a ST0. F divide ST0 STI, divide ST0 by STI and store the result in a ST0. F divide P STI and ST0, Divide the stack pointer I by the stack pointer 0, store the result in a stack pointer I, and pop the register stack. F divide M32 integer. It divides the stack pointer 0 by the M32 integer and store the result in a stack pointer 0. F division M16 integer. Divide the stack pointer 0 by the M64 integer and store the result in a stack pointer 0. The mnemonic and the descriptions are shown here. The FSQRT computes the square root of the whatever the content in a stack pointer 0 and store the result again in a stack pointer 0. F scale, it will scale the stack pointer 0 by the ST1. FPREM replaces the stack pointer 0 with the remainder obtained from the dividing ST0 by ST1. FPREM replaces the stack pointer 0 with the IEEE remainder obtained from the dividing ST0 by the ST1. FRNDINT round ST0 to an integer. Extract separates value in ST0 into the exponent and a mantissa. Store the exponent into the ST0 and push the mantissa onto the register stack. Mnemonic and descriptions are FABS replaces the ST with its absolute value. Comparison instructions are fcomp, which compares the real values, fcomp, which compares the real and pop, fcomp at compare the real and pop twice, ficom integer compare, ficomp integer compare, and a pop ftest which will test, fucom under order compare real, FUCOMP under order compare real and pop, FUCOMPP under order compare real and pop twice, exam that is examine. Mnemonics apps as shown in the fcomp F32FP. It compares the ST0 with the F32FP, fcomp 64FP, which compares the ST0 with the M64FP, fcomp STI compares the ST0 with a STI, ST that is compare the stack pointer 0 with a 0.0. Mnemonic exam, F exam that is classify value or the number in ST0. Exam results the class which is unsupported C3, C2 and C2 having the value 0, normal finite number 0, 1 zeros, infinite number 0, 1, 1, 0 that is a 1, 1, 0, 0, empty. It becomes empty when C3 becomes a 1, C2 becomes a 0 and C0 becomes a 1. Binomial number. Transcendental instruction as shown in a figure, FSIN that is a sine, F cos that is a cosine, FSINCO that is sine and cosine, FT10 that is the tangent of the ST, FTATAN that is the arctangent of the ST1 and IST, F2XM1 that is the 2 raised to power x minus 1. So these are some of the transcendental instructions. Constant instruction are FLDZ which loads plus 0, 0, FLD1 which loads plus 1, FLDPI that loads the pi, FLD2T that is a loads the log 2 10, FLD2E that is a load log 2E, FLDLG2 that is a log base 10 to the 2. Processor control instruction finite, FINIT which initialize the processor, FLDCW which load the control words, FSTCW which stores the control words, FSTSW which stores the status word, FSTSW which stores the status word to the FX, FCLEX which clear the exception, FSTENV that stores the environment, FLDENV which loads the environment, F save, we save the states. FRD, FRSTOR, restore the state. FINCSTP, restore the state. FINCSTP, that increment the stack pointer. FDECSTP, decrement the stack pointer. FRW, free, that is a free the register. FNOP, no operation. And F wait, that is the CPU in a wait condition. Interfacing signal of the 386DX with a 80387. So these are the some of the interfacing signals. M0 with a NSP1, A31 with the NPS2, A2 with a CMD0, a read or a write operation with the read write operation, ADS with the ADS, and D31 to D0. So the data bus with the data bus, busy signal with the busy signal, error with the error. This is the interfacing of the 80386 with the 80387. 80387 having the pins as shown in the reset IN, that is the immediate termination of the parent operation BZ pin. Output indicates the processor is executing a command. Error. Output indicates an unmasked error condition has occurred. PEREQ, if output is high, ready to transfer data. If output is low, data is being transferred to or from a PIC. CMD0 command line for a control of the 80387 operation. NPSI and NPS1 and NPS2. Input indicates the 386 is performing an escape instruction. No data transfer unless these lines are selected. Ready signal indicates the end of the bus cycle signals. This input pin bus is ready. Ready 0. Write the cycles last 2 clocks, read the cycles last 3 clocks, and then terminates. HLDA input inform the coprocessor of the 8036 bus control. STEN status enable serve as a chip select. VSS, that is a system ground connection. VCC, that is a system 5 volt supply. Thank you friends for watching the video.